cumulative flow diagram. You can think of it as a burn-up that shows how a typical Scrum iteration is supposed to work. At the beginning, you select a sprint backlog, a batch of tasks that you're going to finish and release. And then you do the tasks represented by this green area. It's sort of a burn-up chart until you're done, hopefully at the end of the iteration time. And then you release. And if you're very, very lucky, you'll get something that looks like this graph, but it's not very common. One of the problems with Scrum is that you have to get everyone together to do an iteration plan. It's actually possible to skip the iteration planning and save yourself a bunch of time if you use a Kanban process where each contributor, each person just pulls one task to work on. So you only have a number of tasks in your work in progress, it's called, your WIP, that you can work on any given day. You don't have to do much estimating with this either because you don't have to say when you're going to finish. You just have to make sure that you're working on it. And you continue this process infinitely, finishing work. And this is a very clever system, this Kanban system, because it forces you to finish each task as quickly as possible. The problem is most people don't have a continuous process. They release iterations. They have a release process. So for those people, we can adapt the Kanban process into something I'll call scrum-ban. So you can work with a distributed team and skip that iteration plan and just grab off the work in progress that you're going to work on at the beginning and use this Kanban-style process. At a certain point, you say, hey, I need to finish this release. I need to stabilize and release it. So you throw out all the tasks you're not going to finish, which I've labeled here as triage, and then you feature freeze, and then you finish everything you need to finish for the release, and you have a release. And actually, this process can come pretty close to the ideal. This is a fairly big project from Constant Contact, a cumulative flow diagram, and you can see that this green area, the completed tasks, actually does converge. You can see where they did their triage and so on. So I find that if people are using distributed teams, they're actually more likely to be using this scrum-ban process than the Scrum process they think they're using. So that gets you to distributed teams and adds something to scalability. How are we going to get to continuous delivery? The answer is in how you test your software. Obviously, the problem with just releasing every change is it should be tested. And typically when you test software, you merge everything together into a release candidate. And then you have a test system where your QA team can go look at it, and they get stuff fixed, and you merge those changes together until finally your release candidate looks really good, and you release. And I've been doing this process for decades. It's an old, reliable process. It does not get you to continuous delivery because whenever you merge these changes together, there's a chance that you might find a problem. To get to continuous delivery, you actually need to make one and only one change in your thinking, which is to have multiple test systems. So each contributor is going to look at the current production revision plus his or her change. Merge those things together, test them with an automated system, continuous integration system, and call the QA team over as a consultant to test that change. And if everything looks good, boom, you can merge it into the production revision and you can release it. You can see that it's a little more complicated, and specifically there's more merges that are involved in this process. But it also relieves a certain kind of stress, and it simplifies the process in the sense that you never have to worry about what happens when contributor 1 and contributor 2 have a conflict and try to figure out who's supposed to fix it, because essentially as each change goes through, that becomes the master revision. If contributor 1 puts through a change and contributor 2 finds a conflict, it's up to contributor 2 to fix the problem. So it clarifies the lines of responsibility. If you're running one of these continuous delivery systems, you're going to need automated testing. And this slide shows a picture of how we've set up automated testing at Assembla, where each proposed change has a code review object called a merge request, and we have a Jenkins server that will pick that change up and test it and actually vote on it. It'll actually tell you whether it passes all the automated tests. So this is the kind of thing that you're going to be using. Here's a picture of the results we've been getting as we've been exploring some of these tactics. At the beginning of the chart, you can see we were doing a typical scrum-ban cycle of about 2 releases per month. But then we got into trouble. Our release frequency went down to 1 a month because our system became complicated, hard to test. And that's when we decided we need to make the switch to continuous delivery, and you can see that incrementally as we've adopted these tactics, we've moved up the curve. And in fact, by now it's up over 4 per day. That's about 2.5 per day. So we found advantages to releasing smaller releases more frequently. If you aren't like Assembla, if you can't just release whenever you want to your web servers, and you have to go through a batch release process, you can use something called the continuous delivery dial. This is a concept that we got from Serena Software, where they recommend running continuous delivery as far as you can in the development process, keeps the thinking clean in development, and then dropping it into a batch process they call a release train for things like user acceptance testing and deployment. And there's actually an 11 on this dial because if you're a web company, you can release your changes to production on a few servers, test them there, and then merge them back into your production version. To do this with Subversion, you're going to change the way that you use branches. So on the top of this slide, you see the typical Subversion merge pattern, or release pattern, which is to put all your changes in trunk and test them there, and then cut release branches. There's some annoying things about this. For instance, if you do a bug fix, you have to put it into 2 places. With our continuous delivery proposal, you're actually going to be doing all of your work on development branches and all of your testing, and then merging to trunk. So it puts some pressure on the merge process, and there's some merge and review that goes on that you don't need if you just commit everything directly to trunk. Actually, a lot of Subversion users are already doing review and merge. So for instance, if you use something like Review Board for code review, you're going to be reviewing patches, although you're going to be running your continuous integration in QA on the post-merge patch. And if you're like Google and you're running Garrett-style development, instead of patches, you're going to be using temporary branches. And the advantage of a temporary branch is that you can fix it. You don't have to delete the patch and start over. You can just commit a fix to the branch if you find something in code review. And you can also, it's easy for your continuous integration server to access that and test it. So there's a variety of approaches to this rapid review and test process, and all of them are going to involve some sort of review and merge. So how do we do this with Subversion? We're going to have to increase the reliability of Subversion merge with some tactics. So the first thing we did is we wrapped up this whole review and merge process in a web-based UI. So as of today, I'm happy to announce that Assembla has released what we call merge requests for Subversion. You can find them on our site. And this will allow you to manage these short-lived branches, to run code and continuous integration on them, to run code review on them, and it will provide precise instructions for how to merge them back into the correct place, which is a place that Subversion merge often gets into trouble. Finally, we're looking forward to the use of Subversion 1.8, which has a new command called symmetric merge, which makes all of this stuff easier and more reliable. So I'm going to show you a typical process using the Assembla branch and review system. Here you see a Create Branch button. You can also create branches using your normal Subversion client. So you're going to create a branch for a specific task, for a particular ticket. You're going to commit changes, and then you're going to create something called a merge request. You can see it says send merge request. You're going to say, hey, please test and review this change and merge it into trunk. That will get picked up, hopefully, by your testing system, and your testing system will say, hey, passes all tests. Then it goes into a list for a reviewer, one of your teammates, who will look at it. They'll click on that merge request in the list, and they'll get a page where they have instructions for how to get those changes and test them. They can vote, or they can follow the instructions. If everything looks good, they can follow the instructions to merge into trunk. And that's the framework we put around this to sort of increase the speed and effectiveness of code review and test, so you can run one of these processes. And actually, I talked about a number of steps that you can go through to get from iterative Scrum process to a more scalable continuous delivery process. There's a number of steps, and you can adopt them whenever you're ready. Mix and match. You saw from the curve that you can get sort of a smooth motion into continuous delivery. Once you do this, you can actually get a very scalable process. you can have a process which has an essentially very large number of contributors that can be individuals, outsourcers, partners, pulling tasks off of your current work stack, your prioritized backlog. Each of those contributors will have their own on-demand test environment where you can make sure that what they're doing is something that you want. And then you can use this review process to pull your release together and merge what's ready, accept what's ready. So you can run this at a very large scale. I'm now going to hand over the microphone to Scott Rudenstein, who will tell you how to do this with installed Subversion servers with global teams and large-scale development.
Thank you, Andy. All right, let me just click ahead here, and we're going to talk today about distributed subversion. This is for people that have subversion repositories for global teams that they need to be able to do high availability for builds, high availability for continuous integration, continuous delivery. So here are the topics that we'll go through, and as I mentioned, we'll discuss some of the challenges directly involved with having decentralized teams. We'll talk about continuous integration, continuous delivery for enterprises, and then we're going to give you a brief overview of the multi-site technology that WANdisco provides and how that solves some of the issues that challenge teams on a daily basis. We'll talk about a few of the benefits and finally come to a simple conclusion. So let's start out and talk a little bit about what I like to say, is on-premise CI/CD, continuous integration delivery, which is what most companies are doing. So often it happens and occurs at a single site. All of the tools that are used as part of the process are local, and the developers are either at the main site or close enough that internet connections between sites or remote users are robust enough for the task at hand. So if you consider the things that we go through in a normal process that we want to deliver, it's all well and good. Developers can work on a task, update their working copy, they can commit changes to the Subversion server, do their automated builds, and if it's successful, it will go through and have the automated acceptance testing done and the user acceptance testing and move on to release. Having a centralized infrastructure can work well when the team members are in reasonable working distance from the main site or have an excellent network connection. That's one of the things that we want to look at. But what I'd like to talk now about is what about the team members that are at global sites that are not close enough for this model to work? So we're going to explore that over the next few slides here. So let's add to this picture a couple of new locations. For example, we're going to add the UK and we're going to add China in as distributed sites that have a global presence here now and have different team members around there. So the first challenge is the heavy reliance on the network. Where our previous scenario had good connections, we all know that when you add distance, it adds complications and reliability issues. So once again, we have our developers working on a task, and as before, the first thing they're going to need to do is update their working copy. Well, right away, we're faced with our first set of challenges. Depending on the size of the files, there's a certain amount of time that it's going to take to update the working copy, and that has to be done for each developer. After they have what's needed, and they make changes to the code, they need to commit the changes back to the US. And again, this type of commit can take time because everything that they need to do for the builds and the automatic acceptance testing is all US based. And this can take minutes, depending on the type of development that you're doing, or it can take up to hours. Imagine having to push a large binary file back and forth between the sites because that's the type of development that you're working on. The next challenge for the teams is if the network itself goes down. So in this example, let's say for some reason we've lost either our private MPLS line, the VPN connections, or whatever method we're using between the UK and the US. Well, at that point, you can't do continuous delivery because you can't deliver. If the master site goes down, or the only site that we have, this US server, not only does it shut down delivery for the US, it also shuts it down for the UK and for China. Essentially, all delivery, all development stops. And people can work on whatever they currently have, but they can't commit any changes. They can't update any of their working copies. So we're going to add, well, before we do that, we'll just talk to a couple of challenges about to distributed teams. As I mentioned, heavy reliance on the corporate network. It does introduce a single point of failure. Latency or network drops are impediments. Obviously, it can take way too long for files to ship, and you're losing productivity for your developers. And the change set, and this is going to follow on to what we're talking about as we go through this, the change set becomes very important. How big is what we're committing, and how delicate is it to a network drop? So let's now consider the same solution again. And this time we're going to do what I call partial solution. And in this case, what we've done is we've added copies of the Subversion repositories to our local sites. And many of you were familiar with this if you're used to working with Subversion. So we've installed a slave and now have a master copy in the US. And this is going to allow people to have local copies. However, one of the things that we have to look at is, while this will help reduce network traffic, you still have to go through the same steps that we did before. So a developer is going to have a task. Developer first has to go and make sure that the updates are right before he can do any commits that are out there. After he's able to do some sort of commit, that has to actually travel to the United States, right? In the master-slave relationship, we don't commit locally. And before you can do your builds or anything else, we actually have to have that make another trip backwards, so a full round-trip cycle, where now whatever assets I've built and checked into Subversion have come back to our distributed sites. It's a nice concept. It can work well, again, based on the size of the files that you're passing back and forth, the commits that you're doing, and if your network is highly reliable. And if everything works well, then you can go ahead and now add all the same infrastructure that you had the master site, so you can have your continuous builds happening, your automated testing, and as far as you want to go into the process towards release. The problem that we can have is it hasn't addressed the networking issues that we saw in the previous model. For example, if I lose network connectivity, then I can't pass my build, my code over to the US and have it return to where I am, so I can't do any of the continuous delivery that's out there, the continuous integration. And if I lose my master site, once again, everything is shut down and all continuous integration and continuous delivery is stopped. So we don't have any improvement based on the problems that we're having on the network. We still have the same single point of failure. And depending on what's changed, we've now increased or doubled the round trip or the latency that we have to deliver our change sets, just based on the fact that they first have to go to the US and then come back to our remote sites. So we're losing more productivity as developers have to wait for a sync between the master and the slave sites that are out there. So let's talk a little bit about WANdisco and what we do to help solve this problem. So the WANdisco solution, instead of being a master-slave, is more of a peer-to-peer relationship with active-active replication between it, meaning that changes are continuously being written to all of the different sites that are out there. And so as we look at the diagram, imagine in the left-hand side that the US does go offline. And it's 2 a.m. in the US, which means we do have people working around the other parts of the globe right now. Normally in the previous scenarios, they would be shut off and unable to do any work. But because this is a peer-to-peer architecture, development still continues at each of the sites. No one is being shut down. Each of the sites now can do their continuous delivery, continuous integration, until such a time as the US administrators come in to diagnose, is this a network problem, did I have a server down, or what else might be happening? And we answered this with our Subversion multi-site technology. The other thing that we like to look at is managing global permissions. So we've talked about the concepts now that we have these distributed teams, but often we have multiple distributed teams that are out there. And one of the things that we need to look at is the ability to say, here is all the different projects that we're working on, and we'll have one team working on something that's in the United States and also in the UK. We'll have another team working on something in the United States and China, and wow, there is something where we have experts globally that we need 3 different teams and 3 different sites helping us to work on this. Right now, when you add team members in, you usually have some sort of request to IT, where IT is going to go through and add them into either the Active Directory LDAP servers, or they're going to add them in and set permissions in the OSCE file that manages who has access to what. In too many places, I've seen companies do a dangerous workaround where instead of going through and creating the right permission sets, they make it very flat. Everyone has access to everything, and we'll all trust each other not to make any mistakes and damage anything. Other customers have been much more aggressive in getting the right type of permission sets out there, and so they'll do something with Active Directory teams or LDAP teams that are out there and have that propagate into the Subversion system. What we like to say is there's a better way to do it that's all GUI-based. It's our product called Access Control that will manage all that for you and give you more flexibility to add and control your team members, because it allows you to, at the team lead level, whoever's in charge of the project, go ahead and add the necessary team members that are part of your Active Directory structure without waiting or delaying from an IT request. So the benefits when we enable this type of replication strategy is that it lowers cost, it increases quality, because each site truly is a full working copy rather than being part of this master-slave relationship or relying on a single server in the US for a distributed team. It improves collaboration. Instead of being something that is synchronized to get changes updated, or it works off of a trigger to get them updated to the different sites, it's always updating the very latest copies of everything to all of the sites. Everybody can then do an update against their workspace and then do a commit back afterwards. Obviously, this is going to give you a higher quality product. It's much easier to find if you have all the information and code locally, fix all your defects that have happened during each part of the coding phase, and you're going to have much faster release cycles. The last bullet point, developers don't have to wait. I have personally worked with teams that had 6 hours of delay when they hit the button. It's kind of a, I'm going to hit the button, I'm going to go to the copy, or I'm going to just leave for the day because my work is basically stopped while this commit is going through. Imagine the increase in developer productivity and team productivity where everyone is getting the latest changes, able to commit fast, able to commit rapidly. I think back to Andy's example of Facebook trying to commit twice a day. If you were waiting 4 to 6 hours for a commit to happen between India and the US, you would not be able to do that. So in summary, there's a much faster, much more reliable way. We have large customers that depend on these best practices where they have upwards of 4,000 or 5,000 developers all inside of a few repositories that need this type of infrastructure. We have small customers that have the same type of need as well. At the end of this, there is an offer that we'll talk about. I'll turn this back over to John, and he will be able to tell you a little bit more about what we're doing. I want to thank everyone for the time you spent with me, and with that, John, I'm going to turn this back over to you.
Great. Thank you very much, Scott, and thank you, Andy. Just briefly going to talk about the two companies again for a moment, and then we'll open it up for questions and answers. Again, Assembla, cloud-based tools for distributed Agile development teams, free Subversion hosting, excellent set of ticketing and collaboration tools, and now a lot of services related to helping companies implement continuous delivery and highly scalable Agile processes, a lot of the things that Andy was talking about. And you can get a 30-day free trial for several of the tools and services by coming to the website. WANdisco, excellent Subversion services, support, and products that help manage very large-scale Subversion-based development efforts, and you heard Scott talking a lot about those, and you can actually go and try the Subversion multi-site product from WANdisco as well. You'll see the link there on your screen. I want to thank everybody for listening to the presentation part of our webinar, and encourage you to click on the link on your screen and ask questions. And right now we'll do probably about 5 to 10 minutes worth of questions. So please go ahead. And let me start off with one or two. Maybe the first one, Andy, this is for you. Do we need to begin with Scrum, or can we start using Kanban, scrum-ban, or continuous delivery immediately?
I don't think you need to go through a Scrum phase. I usually start there because so many people are doing Scrum. So we like to think about going beyond Scrum. But if you're not doing Scrum, then you'll probably just jump right into scrum-ban or Kanban right away. The key thing is you're always going to be working off a prioritized backlog, a prioritized list of tasks. Once you have that, you can start at any point, grabbing off either chunks or one task at a time.
Okay, thank you. Let's see, Scott, I think this would be for you. Is it really feasible to eliminate single points of failure in the type of environments you're talking about, or do you just minimize them? I guess, let me translate that. How far can you go towards eliminating single points of failure?
Sure. So we have several different methodologies for deploying the WANdisco multi-site technology. In most cases, we're able to eliminate over 90% of what I would identify as risk to a project team, meaning that you eliminate the need for that IT administrator to have to be in the U.S. if it's working hours for China. China's in control of their own destiny. They're working on, like I said, a full local copy. There's always going to be some risk that's inherent to any site, either disaster. There are solutions we also have for helping with disaster recovery scenarios. But I've seen customers that it takes 2 weeks to restore things because they have to ship them around globally, and we can reduce that a fractional amount of the original time as well. So I'd say better than 90%.
I will say that in the Assembla case, we use what we call triple redundant servers. So when you commit to one of our centralized subversion servers, so you can think of that as a single point of failure, it replicates every commit to a failover server, and that in turn replicates to a disaster recovery site at Amazon, where we could conceivably run the full system. And Scott's right. If you have to move these files over the internet is actually very slow compared to the size of the files. So unless you're replicating them in real time as every commit happens, it's going to be awfully hard to respond to a disaster.
Okay, so replication, very important capability. Actually, a quick comment from me, John, that there's a question, is there a way to get the presentation document to share with my team? Yes, the slides will be available, I know, on the Assembla website and probably on WANdisco as well. We'll send everybody an email with information on how to get the slides, and also we've been recording the event as well, so everybody will get that who's in attendance. Okay, here's a question for you, Andy. Have you eliminated ticket effort estimation and product burn downs with scrum-ban?
If you really feel a need to predict and measure your output, you can do estimation, but in my own experience, I found that estimating is actually a really hard task. It takes a lot of time and attention from the development team. And if you've prioritized your task correctly, it really doesn't change what you do. You're still going to do the highest priority task, no matter what the estimate comes down to. So if you're in that situation, you might be incentivized just to skip the estimates and instead get a higher velocity because you're spending more time working on your tasks. It's up to you, but that's always an option that I encourage people to think about.
All right. Thank you, Andy. We'll probably do just a couple more questions, but there's still time to get one in if anybody wants to click the button and ask. But in the meantime, I guess, Scott, how do the techniques discussed improve software quality? Can you relate some of what you were talking about earlier to improving software quality?
Sure. So many people often talk about, improving the process. How many more builds could you get out a year, or are you going to get more builds out a year? Really, by increasing developer productivity, lowering that latency that they have, taking away these long time stretches to commit files, it does allow people to build and test more often. By doing that, you might stay on your same release cycle, but the quality of the software is going to be much higher. You've simply had more time. We have almost all of our customers that use the multi-site technology could be referenced with that type of story. They've all had that massive delay, low productivity out of developers, and then suddenly they have this higher productivity, better quality software coming out of it. And a lot of them have now gone through, and there's a white paper that's available that was written by one of the SCs at WANdisco that specifically map and talk about using Subversion with continuous integration to build that sort of more robust, higher quality environment.
All right, thank you very much. I think maybe we'll just have one more question then, probably for Andy here. What if our customers don't want a new release every day? Does it still make sense to implement continuous delivery?
Yes, I believe it makes sense to implement continuous delivery for the development team, mostly because it's a lean process. So the idea of a lean process is you should take one task and move it all the way through and finish it, so you don't have it in inventory, as they say. It's not a task that's sitting around partially completed. If you do that, your developer can put full attention on the task and then put full attention on the next task. In the typical iterative development process, you finish something, you send it over to QA, and then it comes back 2 weeks later with some sort of a bug report. And you have to reconstruct both your mind and your computing environment to go back and fix that thing. So yeah, that's just one example of the advantages of continuous delivery process inside the development phase. The other examples, for instance, greater consistency of output, the fact that you can skip a lot of these rituals like iteration planning, so I think your productivity goes up. Estimating, for instance, you do measuring instead of estimating. Productivity goes up because of those things. And then there's the scalability, the idea that if you can just pick what's ready from any of a very large number of contributors, if you have that capability rather than having to organize them and manage them in advance, you're going to be able to scale much better. Your organizational task is easier. So those are some of the reasons that I think that even if you're doing an iterative release process, you should take a look at continuous delivery in the development phase.
All right, terrific. Well, I think we'll end right on time here. Just want to mention to everybody, thank you again for joining us. If you go to the WANdisco and Assembla websites, you will get not only information but opportunities to try the products and services on a trial basis. And if you want to contact either of our presenters, you can reach Andy Singleton at simply andy@assembla.com, and there we go, or Scott at scott.rudenstein@WANdisco.com. So we're interested in your comments and questions. Appreciate your being with us. And we will again post the video and make the slides available, so everybody who registered will get an email within a few days with the information on how to get the slides or watch a recording. So thank you very much for being with us.